Hi, everybody. This welcome to Accelerated Computing. This is a continuation of my data structures in Java. In a previous tutorial, I built a fixed array. It's a manual implementation of an array in Java, or just a data structure. It's fixed in size. And then I had a bunch of functions I created for it. Now I'm going to use this fixed array to create a dynamic array. So they're all on the same package, data structures. So I defined it like that. It's a public class and functions are accessible from outside this class, just like I made the fixed array. So these private variables are only accessible from this class, dynamic array class. So that you got the private integer size, capacity, and I'm using the fixed array that I created before. So I'll be creating a fixed array instance when I create the dynamic array. So the dynamic array will be able to, I'm not going to show that in this tutorial, but the dynamic array is going to be able to do that. Each dynamic array instance is going to be able to do all the functions I created for the Java, the fixed array. So this is the default constructor. I set size as 0 and the capacity of the array to 4. And I created this data to be the fixed array. And that was that constructor takes the size. But so when in the fixed array, that's the size. But here is the capacity. Size and capacity is different in the dynamic array because I'll discuss that a little later. The size is the actual, like the number of elements in the array, but it's going to have ability to have a bigger capacity so that we're not always creating new instances. And so this constructor calls the default constructor and just and so when the array goes in, it just appends to this instance that's already been created. So that's basically how that works. And it prints out the size, the capacity, and the elements of the array of the dynamic array. And it has some other functions like if it's empty, it returns the length. I got set at index, so I could set a value at the index. And the fixed array is not type, it's an object. It's an array of object array. So it can be any type. But for the intents and purposes of this tutorial, I made everything integers. But the dynamic array is the fixed array, and they can be any type. They just can't do all the functions in the fixed array. But I set error exception handling for that. And then I have an append function for the dynamic array. I have what's different about the dynamic array than the fixed array, the big difference is you can resize. So, and resize is automatic. So once you start appending values to the array and adding values to it, it's going to automatically resize it. So when the size equals the capacity, it's going to double the capacity of the array, creating more memory. You can see because It's called amortized time complexity. You're creating a time complexity of 1, O to the 1. Whereas if you had to create a new instance, every time the size equaled the capacity, so every time you're appending and it's going to get it's not enough capacity, so you have to create a new array. If you just did that every time, it's going to approach O to the N. And so it's the time complexity is O to the N is basically the number. If there's a million elements, that's O to the million elements, whereas there's a big difference O to 1. Because then usually most of the time you're going to have enough capacity, so you're not always doing this. That's the idea. So I got insert at index. So and so besides the append and recite, after this, the foundation of the dynamic array is set. So now these are additional functions. I kept it. It was easier just to keep it in the same dynamic array class. And inserts a value at the index. It checks, this is going to check index and capacity verification, make sure there exists and the capacity is needs to be resized or not. And then it's going to just set the value at that index. Then every time it does it, it increases the size. Remove at index. It just removes, it does the same thing. It checks the index and capacity. Right there, it checks the index, make sure it's not invalid size. And now, you notice up here, it causes a resize function. Yeah, so whenever like the size equals capacity, it doubles the capacity. So I'll specify that. So it would move at index. This is a little bit more complicated. It checks if it needs to be reduced. So it's only going to be reduced if the size of the array is less than the capacity of the array over 3. So basically, it's an almost empty array. And the capacity has to be greater than 12. So 12, once the array is created, once it starts reducing the size, increasing the size, it's never going to be and it's and then this dot size less than this dot capacity over 3 is making sure that if this array is almost empty, it's going to create a new capacity. And so like right here, the Java math dot max is this dot size times 2. So I'll increase the size of the new capacity. I'll double it. And basically, size and double size. And if it's smaller than 12, the double the size is going to be the new capacity, or 12. It's going to return the larger of the two. So it's always going to be at least 12, the new capacity. And so here's the part where a new instance is created. So the idea is to avoid frequent resizing and capacity manages memory efficiently, because unused capacity is just wasting memory. And so, like I said earlier, reducing the capacity when the array is almost empty frees up memory. So if capacity equals 20 and size equals 5, so that'd be this dot size equals 5 is less than 20 over 3, which is 6, because it's going to be an integer division there. And the capacity is greater than 12, which it is, it's 20 there. It's going to create a new capacity, and this dot size is 5, so you times that by 2, 10 or 12. It's going to return 12. So new capacity is going to be 12 in that situation. So that's how and I created 2 more functions. There's a lot of different functions you can create with Java. They already have built-in functions. I just want to give an example how you can. I put down like a foundation, and if you want to do the other types of functions manually, you could start with this, and this is probably sending down the right path to the correct way to implement it, a dynamic array. So this is a slice array. It just you have a start. It's like the Python slice. You send a start index. So valid, make sure it's a valid start index and size. I create a new instance of the dynamic array class. And so I iterate over the section of the array and append it to this new instance and just return it. And so you can get a slice of the array. Append array is just creating, you have an array and you're just going to send another array to append at the end of it. So you're appending basically 2 arrays together. Okay, so I did some tests here. And so that's how you compile it. Make sure I was in the right folder. And then since in the data structure folder, I call it like this, run main. Okay, so let's go through. All right, so let's go up. Now this is when I was just building the dynamic array, the size and capacity, and then I was just testing it, and I put the number 25 in the next one. And then I'm increasing the size. Let's have it here so we can look at what it's doing here. So there was the initial array. I printed it, set index. It's kind of the initial code. Now, this is when I tested a little bit more in depth. So I just it was quicker. Normally I would just append everything, but I just did it like this. I created a dynamic array this way. So you can see my rotates it to the right. It doesn't overwrite the values in the array. It rotates them to the right. As you can see, each time it gets once I add 3 more values, see the 440 is the last one. You see, like when I insert at index 3, 0, 0, 1, 2, 3, right there. Zero, 1, 2, 3. It's right here. It rotated everything to the right. So, okay, so 660. So you see everything's rotating to the right. And then I got an exception on the -1. Exception was raised. So now remove that index. So I create another object array and just had I just set that as my values. Seemed the quickest way to test it. So you go, let's see, at index 5. So that's value 600. And then you can see I move everything over when I print it out. You see how 600 is missing, and then I start checking out edge cases. Remove at index 0. So you see it started out there. You see here, I guess I could have moved it to the right. It makes more sense to me to move it to the left. Depends on what you want it to do. And then I remove the last one. So the last one was 1200. And you see, I removed that one. So there it is. So I start removing all these. And you see how it moves everything over. Just remove index 0, it moves it over to the left, move index 0, move, it's just so in the slice, let's check that out. Right there. So I got my initial values 100 to 1000. And then we start at index 2. And 0, 1, 2, you start at 300. And the size is going to be 5. So you see 300 to 700. And the next one will start at 0. And so remember, it starts 0 to 3. So there it is. Index 5 and 2 is right here, 600 and 700. And then I tested the invalid exception handling. And now append array. So I create a dynamic array 1, and I append all these values. 500 dynamic array 2. And so it's 6 to 100 to 1,000. And then dynamic array 1, append array dynamic array 2, and you can see that. So remember, dynamic array 1 is going to have all these. So there it is. So that's a quick dynamic array. There's all kinds of functions you could build yourself besides this that are a little bit more complicated. Put a request in the chat thread, and I'll do some if you would like me to. Thank you very much.